A complex number has the following form. It has a real part, and b, an imaginary coefficient. So what we're trying to do with this equation is we're trying to solve it so that we have a be 9 and b be negative 3. So let's try to simplify a little bit. Actually, in second glance, there's nothing we need to simplify because we have the imaginary coefficient right here labeled. And then this would be the real part over here. These are the numbers that don't have an I attached to them, so they're the only real numbers in this whole thing. If you were to distribute this I, you would have a whole bunch of imaginary pieces. So these numbers represent the imaginary. So essentially we need this, the real parts, to be 9 because that's what they all equal over here on this side. And we need these imaginary pieces to equal negative 3. So we need this parentheses to make negative 3. So in order to make that happen, y would be 4. That would make the real part be 9 when you add those up. In order to make it happen over here, let's see. I need to be negative 3. So, actually, I'm not sure off the top of my head. Maybe it's a bad brain day, but let's set up an equation. We want the imaginary part to equal negative 3. So I just took that whole parentheses and I set it equal to negative 3, what I wanted my b to be. So if you add 7 to both sides, you get 3x is 4. If you divide both sides by 3, you get x is 4/3. So these are the two numbers that solve the equation. And again, you can check that to make sure. If you plug in 4/3 in here, 4/3 times 3 gives you 4, and 4 minus 7 gives you negative 3. So we have negative 3i, just like it says on the right side of the equation. And if you plug in 4 in for y, you get 5 plus 4 makes 9. So 9 minus our 3i. Now we have an equation that's solved. And again, if you're not sure how we did that, it's just a little confusing because of the I, but basically you have all your real numbers need to make 9. All your imaginary numbers need to add up to be negative 3. And all of our real numbers are already grouped together. All of our imaginary numbers are here. So we just saw what we need to plug in for y to make this be 9. We just solved by setting this equal to negative 3 to find out what we need to plug in for x to make this be negative 3.